Good afternoon. Good afternoon. Hope all is well and everyone's doing all right. I think everybody's in. All right. Sorry for running a few minutes behind, but we're here now. Good afternoon. Good afternoon. So last class we did 4-4. Yep, those functions. So now we're looking at 4-5 today. This chapter is only 5 sections. Talked about that last class. 4-1 through 4-5. We also talked about that proctoring option or proctoring scenario that we're going to have to implement. Let's see, we got chapter 7, 8. Okay. So let's see how far we get in this section right here. If we get it done, then we'll talk further about how we're going to operate moving forward. And then go from there. All right. So 4.5 is systems of linear equations. So here we have an example of a system of linear equations. X plus y equal to 6, x minus y equal to 2. So this is considered a system of equations. What is this? All right. All right. So we have this system now. We want to find a solution not just for one of these equations, but for the whole system. So in other words, the solution has to work for both equations. That's what I wrote down in the red. The solution has to work for both equations. So we need an ordered pair that make both statements true, not just one. So in other words, if I have 5 plus 1 as an ordered pair, not 5 plus 1, 5, 1 as an ordered pair, 5 plus 1 works here. Because remember, your first component is x, second one is y. So if I had the ordered pair of 5, 1, that would work here because 5 plus 1 is 6. But 5 minus 1 is not 2. So that wouldn't be a solution for the whole system. So we want an ordered pair that works for both equations. So that's what we will be looking for. And so you see right here, the ordered pair that will work for both of them would be 4, 2. 4 plus 2 is 6. 4 minus 2 is 2. So that works for both of these equations. Now we're going to have methods in which we'll be able to solve for. You're not going to just guess, be expected to guess what the ordered pair will be. And we're going to get into that in a second, but I just want to make sure you understand the mindset of what it means to have a solution for the system. The solution has to work for both equations. All right, can I scroll up? All right, so your methods, we have 3 methods that will help you to be able to solve a system of equations. You got the first method is graphing. Next one is substitution. Then the third method is addition. Now I put an asterisk beside the addition because I believe we are not, you're not held responsible for the addition method. I will check to make sure, but I believe that's why I put an asterisk. I didn't put a note. As a matter of fact, let me look real quick, see if I see anything, then I'll go back. Yep, I don't see anything, so yep.
Excuse me, Professor. Before we move on any further, could you just briefly go back over with how that 4 makes the equation, how the 4 work for both equations?
Well, plug them in here. 4 is x and 2 is y.
So what would it be? 4 plus 2 equals 6. And then it will be 4 minus 2 equals 2. So the solution is 4 and 2. Okay. Okay. So solution is gonna always be two numbers. It ain't
Well,
just four.
that's because you have two variables. You have X and Y.
Okay.
Mhm. You know, before all we
Got
had was one variable. It would just be X or it would just be Y by itself, whatever. But now we have two variables, so you need, you know, X and Y.
you. Okay, got you. Thank you.
Just like if we had an equation, 5X plus 3Y minus 2Z equal to 10. Y'all not gonna get this, I'm just saying. Then you would need three because you have X, Y, and Z.
Okay.
Yeah, yeah. But like I said, you guys aren't gonna get that. I was just saying if you had three variables. Okay. And so we're not going to use the addition method, but I was just throwing it out there now. If somebody knows how to use it already, then feel free to use it. Because no matter what method you use, you'll always have these three scenarios. The first scenario is you will get one solution, like 4-2 is a solution. And of course, you wouldn't write one solution. You wouldn't write X, Y. You would actually write the answer. So if your answer is 4-2, then you would write 4-2 as your answer. So that's the first scenario. Second scenario is no solution. It is possible to get that nothing will work, and then infinitely many solutions. That means a whole bunch of stuff will work. A whole bunch of ordered pairs will work.
Scenarios and outcomes. Oh, where you right back?
All right. Can we scroll up? Okay, so we'll look at the first scenario, the first method, solving by graphing. All right. So we're going to graph each equation on the same plane, and then where they intersect, that will be the solution. All right, can I scroll up? So remember I mentioned that each method, no matter what method you use, there will always be those three scenarios. One solution, no solution, or infinitely many solutions. So I'm going to show you generically, before we actually go to graphing, generically how if you decide to use a method of graphing, how it will look for each one of those three scenarios. Anybody still holding on to black? Okay, so here we have scenario one. And so you have two different lines, you graph them, where they intersect, that's where your solution will be. Scenario two, parallel lines. That means they will never intersect or never cross. I'll leave cross the way it was. And so that means there will be no solution. So, if where they intersect or when they cross, you get one solution. If they never intersect or never cross, you'll get no solution. So your lines have to be parallel. And then third scenario, if you have two lines, when you graph your two lines, they end up being the same line. That's when you have infinitely many solutions. All right, questions before we go graphing? Now, when we start graphing, you would use the same graphing methods that you would when you would graph just one line. You're just doing the same thing for two lines on the same plane. So remember, we could graph by generating XY chart. You can use your slopes, slope intercept, or you can use your intercepts, X and Y intercepts. So either way, whatever way you want to use the graph. By this point, they expect you to have um, a solid foundational graph, and then you have your own little system as to how you're going to graph your lines and comfortable, being comfortable with it. Can we scroll up? All right. So let's look at the first one. This is the actual first example that I gave you. X plus Y equal to 6, X minus Y equal to 2. So if we do this correctly, I'm going to go ahead and graph both lines. And if we do it correctly, when they intersect, it should be 4, 2. All right. So what I decided to do first, let's see what I want to say. All right, so I chose to graph by creating an XY chart. You could use your slopes or you can use your y-intercept and x-intercept. It does not matter. I decided to do it this way for this one just to show you different ways you can do it. The next one, I believe I used your slopes. So always label my equations. This one I called equation 1, bottom one I called equation 2, just for board purposes, so you know which one I'm talking about when I reference it. So looking at the first one, x plus y equal to 6. When I graph, I always solve my equations for y. It just helps me in comparison and generating points. If you don't do that and you have your own way, that's fine. But I always solve my equation for y, and that's what I did here. And so I subtract x from both sides. And that's y equal to negative x plus 6. Then from there, don't forget you choose these x values, plug them in and find the corresponding y value. That's what I did over here. Plug in -1 for x, So it's -1 plus 6, and it'll give me a +7. Plug in 0. 0 plus 6 is 6. Plug in 1. That's -1 plus 6, which is 5. And so that's how I got these ordered pairs right here. -1, 7, 0, 6, and 1, 5.
Okay, Professor. Let's go back to our very first step. So when we did the -x, we always get confused. When do I divide and when do I add or subtract?
Well,
This one here.
yeah, well, if you're trying to do that, then you have a positive x right here. You're just trying to take the x and bring it over here to this other side of the equation. So you would just subtract the x from both sides.
Okay.
You would divide you would divide if you had something like this and you were trying to move just to 5.
Okay, so only when I'm trying to move the variable. Oh, wait a minute. Is x the variable? Or
no,
5 is the variable?
x is the variable. 5 is just the constant, the number, the coefficient. So only if you're trying to move the number off of your variable is when you would divide both sides.
We divide. Okay. 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 So this here is just the 6, because I'm looking at that as 6 minus x.
Yep, you can write 6 minus x. It's the same thing.
So I'm thinking that's x is considered 1. So why it ain't 5?
But you got a variable right here. You can't combine these like terms. One has a variable, the other one doesn't. So if you had 6x minus x, then that would be 5x.
Okay.
But they both have to have a variable.
Yeah. Okay. 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 So y equals -x plus 6. Okay. Okay.
All right. All right. Is anybody still copying this purple over here before I scroll up?
Yes, I am.
All right. So I did the same thing for the next one. Say again.
That's okay. I'm good. Thank you.
Okay, no problem. So I did the same thing for the next one. I just want to turn this blue. But I solved it for y. All right, so what I did first was I added y to both sides because I took my y over, I had a negative y. So y's cancel. And then subtract 2 from both sides. I think I want this to be red too. And subtract 2 from both sides. That'll be y equal to x minus 2. All right, so once again, you choose these values right here. I chose -1, 0, and 1. Then I plug them into this equation, which is this over here. So -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. Questions on what we did before we graph or look at the graph? All right. So we have this XY chart here that represents equation 2. And then we have the one over here that represents equation 1. So we're going to graph those points. This purple line is my equation 1. That's -1, +7, 0, 6, then +1, up 5. That's how I got those 3 points. And then the next one is -1, left 1 down 3, 0, -2, and then to the right 1, down 1. And I got this line right here, the green line for equation 2. And so you see my tick marks are a little off, just because, I had to create this. And so, I didn't do it with the accuracy that's needed. But if you were to put this in a graphing tool, you will see that or if you were to do your tick marks correctly, sometimes I get it right, sometimes I don't. But if you have the right spacing, equal spacing, then you will have it at 4.2. And so when you go to graph this in MATLAB, which they're using the grid and everything like that, this will intersect at 4.2. All right, questions before we do another one? All right, can I scroll up? Hold on, so you think I use the slopes here? Okay, gotcha. All right, are we done with this last problem? Okay, so here we have 2x plus 3y equal to 12, 4x plus 6y equal to 30. And so in both cases, I solve my equation for y. Equation 1 over here, equation 2 over here. So in the first one, I minus 2x from both sides. So the whole 2x will be on the right. That cancels out on the left, leaving me with 3y equal to 12 minus 2x. Divide by 3. And don't forget that 3 has to divide into both of these terms. And so that's what I emphasized here. -2x over 3 plus 12 over 3. And I get -2x plus 4. I said -2x plus 4, -2/3 x plus 4. For equation 2, same process, just different numbers. We subtract 4x from both sides. Divide both sides by 6. That'll give us -4 6x plus 30 over 6. Simplify that, I have -2/3 x plus 5 equal y. Give you a chance to finish copying that down. All right, scrolling up. So after we have both of our equations solved for y, simplify as much as possible. Like I said, this is one of the reasons why I like to solve for y is I can compare both of my equations. Remember the number that's attached to your x variable, the one that's sitting in front of x is your slope. And so we see that the slopes are the same. If the slopes are the same, that means we have parallel lines. And since we have parallel lines, that means our answer is no solution.
So how we know both slopes are the same, Professor?
The number that's sitting in front of x, that's your slope.
Which is m, which signifies slope signifies m, right?
Mm-hmm.
Both numbers, you said both numbers in front of the x are the same.
Mm-hmm.
Okay.
All right. So Math Lab still may ask you to graph them. So I decided to graph using the slopes in this case. Since we already have it solved for y, and we're comparing our slopes. We know our slope is -2/3. That means we're going to go down to right 3. And for equation 1, our y-intercept is 4. Same slope for equation 2, but our y-intercept is 5. So here for the purple line, we start at we start at 0, 4, and then we go down to right 5. That gives me that point. And then we start at 0.5 or 0.5 down to right 5, and that gives us that point. And so that's how I got my two lines. All right, questions. All right, let's scroll up. Look at the next method. All right, so substitution method, have some steps here. That if you follow the steps, should be all right. So we want to solve one of the equations. Put one of the variables. Next step, we're going to substitute the result from step 1 into the equation not used. And I'm going to show you each process step by step. So right now, we're just writing it down. Step 3, solve for the remaining variable. Can I scroll up off of step 1? All right. Substitute for step 4, substitute the solution from step 3 into the equation from step 1. Solve, and then step 5, final step is always check. All right. Ready to try this out? Am I still copying the steps? All right, so we have a first equation down there. 2x plus 4y equal to -6, x minus 2y equal to -5. Now, if you go back to the first step, it does not say that you have to solve for x or you have to solve for y, and you have to use equation 1 or equation 2. It does not matter which one you do, which one you solve for, which equation you use. As long as you stay correct in your mathematics, you still will eventually come up with the right answers. But you always want to look for the easiest route to go if possible. So if you look at this second equation and then look at solving for just the x is sitting there by itself, then that will probably be the easiest route to go. So you're starting off with equation 2 and you're solving for x. And so that's what we did here. Took equation 2 and we added 2y to both sides. All right. X is equal to 2y minus 5. Problems with step 1. Step 1 is to take one of your equations and solve it for one of your variables. That's what we did here. All right. Step 2 is we're going to take the other equation. Notice we started off using equation 2. So the next equation starts off using equation 1. All right. And then we're going to take 2y minus x and plug it in to equation 1. And so that's what we did here. Didn't do any calculation, just did the substitution. We took 2x minus 5, that's equal to x, and we plugged it in 4x in the other equation. So this other equation was 2x plus 4y equal to -6. So now instead of x, you see 2 times 2y minus 5 plus 4y equal to -6, because x is equal to 2y minus 5.
Okay, Professor, x is equal to 2y minus 5. Where that other 2 coming from in front of that 2y minus 5?
It was here,
Where?
right here. It's a part of your original equation. See, that's 2 times x.
Uh-huh.
And all we're doing is taking 2y minus 5 and putting it right here for x.
Because why we got rid of the
Because of what now?
I'm trying to figure it out. Let's go back over that one again.
Well, all we did was plug it in for x. You substitute in 2y minus 5 for x.
So
you take this equation and you see where x is, right? It's 2 times x.
uh-huh.
So you're taking that whole expression, 2y minus 5, and plugging it in for x.
Oh, okay,
See, everything else
That's
still the
what's
same.
replacing the x, but the 2 stays there. Okay,
The
gotcha.
4y is still there, the -6 is still there, everything's still there. You just substitute in 2y minus 5 for the x.
Gotcha. Okay.
Mhm.
Okay. Got
All
that
right,
part.
cool.
So
Everybody
that's
good?
the answer?
Well, that's just the end of step 2, that's all. Because I'm doing it
Uh,
step by step according to what we have right here.
Uh-huh.
We're just doing
Okay.
each one step by step. Yeah. So that's the end of step 2, just substitute it in. Now, step 3 is actually, doing the calculation and solving and simplifying. So you go ahead and distribute 2. 2 times 2y is 4y. 2 times that -5 is -10. Still have 4y back here, and you still have equal to -6. That's where we at right here. Combine your like terms, 4y and 4y is 8y. So you should have 8y minus 10 equal to -6. All right. Then from there, you try to solve for y, so you add 10 to both sides, and then divide both sides by 8. Y would be equal to 1/2. Questions before we go to step 4? All right. So now you're going to go take that y equal to 1/2 and plug it into that first equation that we solved for. This one right here, y equal to 2y minus 5. I mean, x equal to 2y minus 5, excuse me. So plugging in 1/2, that's 2 times 1/2 minus 5. That'll be 2/2, which is 1. 1 minus 5 is -4. So x will be equal to -4. Any questions before we go to the next one? So our answer is -4 1/2. All right. Good to try it one more time. So here we have 7x minus 3y equal to -14 and -3x plus y equal to 6. Step one, once again, is to solve one of your equations for one of your variables. It doesn't matter which equation you use, and it doesn't matter which variable you solve for. So the easiest one to go solving for in this case is y in the second equation. So that's what I did here. Just added 3x to both sides. Y is equal to 3x plus 6. All right. Everybody okay for step one? Now, since we used equation 2 in step 1, now step 2, we have to use equation 1. And we're going to take this y and plug it in for y in the other equation. So y is equal to 3x plus 6. And you plug it in for y in the other equation. So everything else stays the same. 7x minus 3 times 3x plus 6 equal to -14. All right. So now you go ahead and solve. Distribute that -3 into the parentheses. So it'd be -9x minus 18. So 7x minus 9x minus 18 equal to -14. Combine your like terms. 7x minus 9x is -2x. Add 18 to both sides. And then divide both sides by -2. And x is equal to -2. All right. Questions, questions, questions. Now that we have this part of our ordered pair, we have x. We go back to our first solving. We have y equal to 3x plus 6. And we plug in at -2 4x. So that means y will be equal to 0. All right. So that's your answer, -2, 0. -2 for X, 0 for Y. Questions? Any questions? I can scroll up. All right. So the next two scenarios, just things that we talked about before, but fits into what's going on now. So remember we talked about before when a variable is canceled and we have a false statement, our answer will be no solution. So when we go about solving these, and if our variables cancel and we end up, let's say with 2 equal to 5, that's not true. 2 is not equal to 5. Something like that, then our answer is no solution. Then if variables cancel and we end up with a true statement, so let's say 2 equal to 2, then our answer is going to be infinitely many solutions. All right, gonna scroll up. Okay, so let's look at this one. 5x minus 2y equal to 4. Negative 10x plus 4y equal to 7. Now in this case, it doesn't matter which one we solve for first. We don't have an x or a y that's by itself like in the other equations. So it doesn't matter which one we solve for. It looks like I chose the second equation and solved it for y. So I added 10x to both sides, divided by 4. So I have y equal to 10x plus 7 over 4. So notice I left it like this just because the 4 doesn't divide to either one of those numbers evenly. So I just left it like this. Any questions on step 1? Still following the steps. So step 2 is to take this equation and plug it into the other equation. So we put that in there for y. So we have 5x minus 2 times 10x plus 7 over 4 equal to 4. All right. So we can look to simplify this. So the 4 has to go into each term, and that -2 has to multiply each term in that parentheses. So that's why I tried to simplify there. So the -2 times 10 is 20x. -2 times 7 is -14. And then divide each term by 4. So that's what we got going on here. 5x is still here, 4 is still over here. And of course, all of your problems won't be this involved, but can't promise you won't see 1 or 2 like this where the fractions are still involved and stuff. So worth walking through it. So now we can simplify. 20 divided by 4 is 5. 14 divided by 4, it would be a decimal if you take the 4 all the way into it, but I just simplified it as 7/2. So notice our 5's canceled over here. And that'll be -7/2 equal to 4, which is false. So that means our answer is no solution. So remember, once again, the variables cancel, and you have a false statement. -7/2 equal to 4 is false. That means your answer is no solution. All right, questions? Any questions? Got one more scenario. All right, very good. All right, so last one, I believe it's the last one. We have y equal to 3x minus 2, and we have 15x minus 5y equal to 10. So remember, your first step is always to solve one of your equations for one of your variables. So in this case, we don't have to do it because it's already done. Y is equal to 3x minus 2. We already have one of our variables solved for here. Y is by itself. So it's already done for us. And that'll be our step 1. Then we plug it into the other equation for y. 15x minus 5 times 3x minus 2 equal to 10. Excuse me. Just following the steps that we laid out. Then from there, distributing -5. So that'd be 15x minus 15x plus 10 equal to 10. So 15x minus 15x cancels. That leaves you 10 equal to 10, which is true. Remember we mentioned if you have your variables canceled and that leaves you with a true statement, there will be infinitely many solutions. Questions, questions, questions. Everybody good? That's it. That's the last one. All right, so is everybody straight? No questions before I go to another page? All right, so that is it for chapter 4. Remember, we talked about how we were going to do this test. We do have to have a proctor test. So today is Monday, so we really can do it next Monday. Well, we'll see how Wednesday turn out. So today is the 21st. Looking at the 23rd. Monday, Wednesday, and that should be the 28th. All right, so today we just knocked out 4.5. So next class will be review. You know, you guys bring your questions. Take a look at the test review. No, we're talking about test review. It'd be test 4 for us. Test review 4. Take a look at it and see if you have any questions. See if you have any problems you want me to walk through or run through. That'll be your day to do and generate whatever questionnaire scenarios you want to generate. I won't do anything new on next class. So we will have the actual test 4 on next Monday, unless we have so many questions right here that I see a need to push this to the 30th. But that will be completely dependent upon what you guys bring to the table. All right. So as of right now, test day is going to be 3/28. And I'm going to send you guys an email with a list of how we're going to operate on test day. Basically, you'll come to the test, enable your camera. You know, I don't normally make you do that. That's the only time I do require that you do is during test day. Enable your camera, show your ID to Zoom. Show your ID to Zoom, excuse me. And then I will give you the password. And then from there, you would just type in the password like you would any other, go into Math Lab like you would any other Math Lab, take any other Math Lab assignment and type in the password, and then you just take the test. And of course, you would stay logged into Zoom so your camera will stay on. And you would just knock out the test there. So don't forget, if you don't do as well as you like on the test day, and a proctor option will pop up, in which the highest score you can get is 85. Or if you know you're just gonna bomb it on that day, then you can just wait for the test to pop open. And like I said, same thing will occur. It'll just be the makeup. All right. Questions? Any questions? Everybody good? Everybody straight? Okay. So next class, we're looking to review. Like I said, bring your questions so we can make sure you're comfortable going into that test. If you guys are good, I am great. And I will see you next class.